This is block 2 of topic 1. In this lesson, we're going to learn how to develop and apply ordered pair rules for both reflections and rotations of points in the coordinate plane. So before we get started, we're going to have a little algebra review that will be necessary for today's lesson. So on number 1 on your notes, you're asked to graph line y equals x on this graph. So a lot of students, when I first have them do this, they kind of go blank. They don't remember how to graph a line. So let me just remind you of a few things. When your y is by itself, then an equation is said to be in what's called slope-intercept form. So y equals mx plus b should look familiar to you. We know the number in front of x is the slope of the line, and the constant is the y-intercept, or where the line crosses the y-axis. So this equation is in slope-intercept form. The number in front of x, since there's not one, is an understood 1. The constant, since there's not one, is an understood 0. And so that slope of 1, we think of slope as rise over run, so we can make 1 a fraction by simply putting it over 1. So if I write the equation like this, you should be able to see everything necessary to graph the line. The y-intercept is 0, so that means I'm starting at the origin. That's where it's crossing the y-axis. My slope is 1, so that means from that point I'm rising 1 and running 1, rising 1 and running 1. So these points are on my line. So in other words, the equation also tells me that for every single point, the x and the y coordinates are exactly the same number. So the point 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on are on that line. So I can use my straight edge here to connect those points and graph the line y equals x. That is the line y equals x. So again, the slope of the line was 1. The y-intercept of the line was the point 0, 0, or it goes through the y-axis at 0. So that's going to be necessary for an activity that we're going to be looking at today, or a certain reflection. So if you'll remember, a couple of lessons ago, we reflected point P, as pictured here, across line M, and we created its image point, which we labeled as P prime. We labeled the intersection where it crossed line M as point M, and we said that since this fold created a congruent segment, we knew that PM, that segment, and P prime M were congruent to each other. We also know that these two angles, AMP and AMP prime, are congruent to each other, and they make a line together, so we knew they both were right angles. So we concluded that line M was the perpendicular bisector of the segment between our original point, which is called the pre-image, and our reflection point, which is called its image. So on your notes here on number 2, we are going to reflect a figure, triangle COT, across that line. We just reviewed what that line was, y equals x, and so that is graphed for us already on the line. So I want you just a minute, just predict, where do you think the reflection is going to end up when we reflect this triangle across this line? And then we'll see how good of a predictor you are with our results. So you're going to need a piece of patty paper and a straight edge for this, so if you don't have that, you'll need to pause the video here and go get that. Again, I'm at home and I didn't have patty paper, so I'm going to use parchment paper, which will work just fine. So what we're going to do is we're going to put our patty paper on top of the figure, and I want you to trace the line y equals x from this point 0, 0 all the way up to this top point up here. And you can use your straight edge, or if you have a steady hand, you can just trace it. That would be great too. And then I'm going to trace this triangle COT. Again, you can use your straight edge, or if you have a steady hand, you can just trace it. And so on my patty paper, I'm going to label this COT. And you can see that I have the triangle and the the line y equals x traced. So we are going to reflect across that line, so that means I'm going to flip my paper. I'm going to line back up my paper with that line at 0, 0, and up here at the corner. And since I'm not using a pencil, I'm going to have to trace down really hard here to make sure that I have an imprint on my paper. Since you're using a pencil, then yours definitely should show up on yours. Okay, so when you lift up your paper, you should be able to see your triangle, as I can with my pen here, as the reflection. We're going to label those points, remember, with prime notation. So this is the reflection of C, so this would be my C prime. This is the reflection of O, so this is my O prime. And this is the reflection of T, so that's my T prime. Now that's labeled, and that's certainly all you'd have to do to label it, but I want us to notice something about the coordinates. So I want you to go ahead and put the coordinates of these points out beside them so we can see what happens when you reflect across that specific line, y equals x. So this point O is at the point 6, 4. This point C prime is at the point 5, 2. And T prime is at 9, 3. So we're going to do a couple of things here for number 3 on our notes. It says draw dotted line segments connecting each point in its reflection. So you might want to use a straight edge for this too. I'm going to draw a dotted segment connecting O to O prime. I'm going to connect T to T prime. And I'm going to connect C to C prime. Okay, so our questions are, how are the dotted segments we drew related to our reflection line, which is y equals x? Well, you can probably see that it appears that we're creating right angles at those intersections. And so the relationship is that they are perpendicular to one another. Our dotted segments and our line y equals x are perpendicular. How are they related to each other? Well, they're clearly not the same length, but they are parallel to one another, is the relationship we're looking for there. What are the slope for each of those segments? Well, this line, remember, had a slope of 1. It's a positive slope because it's going uphill. All of our lines are going downhill, so remember that means from algebra that they have a negative slope. So if you look at the rise over run, if we're going from O to O prime, for example, I have to go down 2, so my rise would be a negative 2, and I have to go right 2, so my run would be a positive 2. Well, we always simplify slope, and that would simplify to a negative 1. We can see the same would be true from C to C prime. We would go down 1, 2, 3, so that's negative 3. Run 1, 2, 3, that's positive 3. Negative 3 over a positive 3 would be negative 1 as well. And you could check T to T prime, it's going to be the same. It's down 6, right 6, and that is negative 6 over 6 is negative 1 as well. So the slope is negative 1. So we're going to compare the coordinates now and see if we can figure out what is the rule, what happens to the coordinates every single time. So if you see, T that was 3, 9 became T prime that was 9, 3. O that was 4, 6 became O prime, which is 6, 4. C, which was 2, 5, became C prime, which is 5, 2. So hopefully you can see a pattern there that what we're doing is the x and the y coordinates are changing positions. They're switching with one another. So we're going to fill in these statements on number 4, parts A and B, and our word choices are x, y. Now you might read that as negative x, but I really want you to get in the habit of calling that opposite x, because the original x may be negative and this sign makes it become positive. So this is x and y, the opposite of x, the opposite of y. The phrase stay the same, are interchanged, and have their signs changed. So it says when the pre-image is reflected across the line y equals x, the x and y coordinates of the pre-image and the image, and what happened to them? Remember, they switched places. So the phrase we're looking for is the one are interchanged. They switch places, or in other words, they are interchanged. And an ordered pair rule, I could just notice a little spelling error here, and I noticed another one up here. This should be then. So, sorry. Just have to correct those little errors. But the ordered pair rule is the same thing as a coordinate rule. You might hear that sometimes too. So just know that means exactly the same thing. And when you write an ordered pair rule, you always start with a generic point x, y. The arrow means you're mapping every point to a new point, and you're going to tell what's happening to those coordinates. So if your original point is x, y, and you're reflecting across y equals x, that means that those two coordinates are changing places. So the y is going to be your new x, and the x is going to be your new y. So that is the ordered pair rule for reflecting across the line y equals x. Just switch their places. So, for example, if your original coordinates were 6, -9, then when you do a reflection across the line y equals x, your new point is going to be -9, 6. They just switch places. All right, we're going to look at this a little bit farther with rotations in the next video.